explanations for like quantum physics, like the double slit experiment and those sorts of things. The Copenhagen interpretation and the multiverse and all there's like 15 different theories there on the Wikipedia page. To
Yeah.
me, this indicates that there's something wrong with the field, not wrong with it, but that there's some conceptual problem that hasn't been solved yet. And so none of these is emerging as probably the right one, and the rest of them are probably wrong.
Well, there's Michael Shermer there talking about which interpretation of quantum mechanics is probably right and probably wrong. Now, of course, this vision of the way in which to arbitrate between explanations and science is itself wrong. Not probably wrong, just wrong. There is no way of probabilistically assigning credence to a given theory which causes it to be less valid. There's no way of conjuring the number. You can talk about Bayesianism all you like, but the point is that no Bayesian analysis is ever going to allow you to calculate the prior probability that a particular theory is actually incorrect. And many Bayesians will say, well, hold on, you don't calculate the prior probability. Exactly. How do you come up with the prior probability, the initial prior probability? I'll tell you how. And the Bayesians are quite upfront with how. When you press them on it, or when you read the literature, you need a subject matter expert to have a guess as to what the initial prior probability of a theory being true actually is, or the truth content, or the credence one might have in a particular theory. So, for example, you might assign a prior probability of the truth of Newtonian gravity to be 65% or 0.65. And then as you do more and more experiments, which apparently do not refute, fail to refute, or in other words, in their terminology, confirm the truth of Newton's theory, that prior probability can be reassessed. You can update your priors, so to speak, and the prior probability of Newton's theory being correct goes up and up and up and up every time an experiment agrees with the theory. And so, of course, as I have said very often on this podcast, on that theory about how science works, namely Bayesianism, that you can actually increase your credence, increase your confidence in a particular theory being true or probably true or something like that, as you gather more evidence or as you have confirming instances of these particular theories that allow you to say, this observation agrees with my explanation. So therefore, every time you drop a ball, every time you observe a planet moving in its orbit, every time you see the tide go in and out, and all of these things apparently agree with Newton's theory of gravity, your confidence that Newton's theory of gravity is true increases, your prior probability increases, and so you go from 0.65 or 65% likely to be true or whatever, however you want to phrase them. It goes up to 70, 85, 95, 99. Asymptotically getting closer to 100. I don't know if they ever get to 100. Maybe they don't. They probably can't. Probably. And so on this analysis, Newtonian gravity, you become more and more confident in it. Every observation that you make up until the moment that it is refuted, falsified by experiment in light of a better theory like general relativity. In other words, the maximum confidence you have in the theory being true is immediately prior to it being shown false, which apparently only takes one observation. It takes you one experiment and a better theory in order to show the thing is false, which is the Popperian view. It's just that the Popperian view, you don't bother ever going through this charade of saying this theory is probably true or 0.65 true or 65% true or anything like that. You don't need to say that. All you say is that it is the best known explanation, the best explanation that we have right now. Phrase it however you want, but you don't need to assign a number to it. In fact, assigning a number pretends precision in an area where it's not required. You don't need to. You just have a binary a simple binary between this is the best explanation of a given phenomena or it's not. This is shown to be false or it's not yet. And so that's the position we're in with respect to general relativity, quantum field theory, quantum computation, neo-Darwinism, evolution by natural selection as implied by the selfish gene theory, all of this kind of stuff, Popperian epistemology, all of this kind of stuff, we just say it is the best known explanation yet to be refuted, but we should expect that, like all extinct theories, that one day our extant best theories, the things we regard as being our best knowledge, will one day be improved, or technically speaking, superseded, refuted by a better theory, and perhaps, in the case of science, observations which rule in favour of a better theory against a worse theory in light of the observation.